Use the trapezium rule with 5 ordinates to work out this integral here to 3 decimal places. Let's get the value of h first then. H equals b minus a. Here's b, here's a. So it's 1.4 minus 1 over b minus a over the number of intervals. 5 ordinates means that there's 4 intervals. This is 0.4 on top. Divided by 4 is 0.1. So there's h. So we've got 5 ordinates then, so let's start with x0 and go up to x4. And we start at 0, we finish at 1.4. There's 4 intervals, so they go up by 0.1s, don't they? It starts at 1, if I can write that correctly. And then it's 1.1, isn't it? 1.2, 1.3. Now we need y0, which is ln 1, which equals 0. Log of 1 is 0. Y1, y2, y3, and y4. So this is ln 1.1, ln 1.2, ln 1.3, and ln 1.4. In this case, rather than evaluate these as 5 decimal places, which would be sufficient to get an answer to 3dp, it's easier to just write these down explicitly rather than the decimal equivalents. So the integral then, in this case, will be h over 2. H is 0.1. 0.1 over 2 is 0.05. The first and the last added together, so 0 plus ln 1.4 is just ln 1.4, plus 2 times everything in between. So that would be ln 1.1 plus ln 1.2 plus ln of the 1.3. Close the bracket for the 2 times and then close the brace at the end. Let's tap that in a calculator then and see what we get. So we get 0.05 times bracket ln 1.4 plus 2 times bracket ln 1.1 plus the ln 1.2 plus the ln 1.3. Close that bracket, close the bracket for the 2 times, and then close the final bracket at the end. And we get 0.0708, so to 3dp it would be 0.071, wouldn't it? And that was to 3 decimal places.